Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 15 video on the topic of floating and sinking from the chapter of Physical Quantities and Measurements. So this is case 2 regarding the floating and sinking of a body in a liquid, where I will discuss that a body with a density uh, equal to the density of a liquid will float in the liquid. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 15 video on the topic of floating and sinking, where I will discuss what happens when a body is immersed in a liquid having a density equal to the liquid density of the liquid. Okay, so I have so this is the figure as the previous video where I discussed about the case 1, that a body will sink if the density of the body is greater than the density of the liquid, that is rho 1 is greater than rho 2. In this case, if rho 1 is equal to rho 2, rho 1 is the density of the body. Let's consider the CGS system. So let density of the body is rho 1 gram per centimeter cube and density of the liquid is rho 2 gram per centimeter cube. Now, if rho 1 is equal to rho 2, then the body floats. We will try to understand why is it so. Also, let's say the body is immersed in the liquid, and let's say some part of the body is immersed in the liquid. That is, the body is partially immersed in the liquid. And let's say V is the total volume of the body, and the part of the volume of the part of the body immersed in the liquid is V dash ml. Now, when does a body floats? Why a body floats? A body floats when the net force acting on the body when immersed in the liquid is zero. A body floats means that it is not moving down nor it is moving up. When will it happen? It will only happen when there is no net force acting either vertically downwards or vertically upwards. That is, the net force is zero on the body. We know that from the Archimedes Principle, we know that the net force W, which I term as W dash, is equal to W, that is the weight of the body, minus the buoyant force. Fb is the buoyant force. This is the net force or net weight, or we termed as apparent weight, that acts on the body when it is immersed in the liquid. Now, the body will float whether partially or wholly immersed in the liquid only when the net force or the apparent weight is zero. Actually, net force on this zero. So the body floats when the net force is zero. Okay. Now, what is the net force? The net force we know is W minus Fb. This implies the net force is W minus Fb is equal to 0, and this implies that W is equal to Fb. So when the buoyant force becomes equal to the weight of the body, then the body floats. Now, why is it that? So definitely it must be the case that when the density of the liquid and the body are same, then the weight of the body becomes equal to the buoyant force. Let's see whether this is true or not. If it is true, then it is justified, it is verified that when rho 1 is equal to rho 2, then the body will float. Okay. Now, what is the buoyant force? We have considered that the volume of the body which is immersed in the liquid is V dash ml. So, the buoyant force Fb is equal to the weight of the displaced liquid, which is equal to mass of the displaced liquid gram force. Now, what is the mass of the displaced liquid? It will be V dash rho 2. V dash rho 2 is the mass of the displaced liquid, because the volume of the displaced liquid is equal to the volume of the immersed part of the body, which is V dash ml. This much ground force. Now, what is the weight of the body? We have considered V ml to be the volume of the body, and we know the density of the body is rho 1 gram per centimeter cube. So definitely the weight of the body will be its mass, which is V rho 1, this much ground force. So now since now let's see whether if rho 1 is equal to rho 2, can W be equal to FB? Okay, now since rho 1 is equal to rho 2, I can rewrite FB as V dash rho 1. Because rho 1 is equal to rho 2, I can write rho 1 instead of rho 2. So FB is V dash rho 1 GF. Now let's see if FB can be equal to W or not. W equal to FB then implies that V rho 1, W is V rho 1, ground force is equal to FB, that is V dash rho 1 ground force. This implies I can cancel V from both the sides. Sorry, I can cancel rho 1 from both the sides, and also I can ignore the unit, that is ground force. So clearly now I can see that this equation becomes V is equal to V dash. So what does it mean? It means that if what is V dash? V dash equals to V means the volume of the immersed part of the body is equal to the volume of the body. This means that the body is fully immersed in the liquid. This implies that body is fully or wholly immersed in the liquid. So what do we infer? When the density of the body is equal to the density of the liquid, when rho 1 is equal to rho 2, and then the body will float. The body will float. And when the body is floating, in what condition the body will float? Will it float partially immersed or wholly immersed? We clearly saw that if the body floats, then V dash is becoming equal to V, which clearly means that the body will float in the liquid, but it will be wholly immersed. So the actual scenario, when rho 1 is equal to rho 2, then the body will float in the liquid, and the scenario will be like this. The body will float in the liquid, but it will be wholly immersed in the liquid. That is, the entire body will be just below the surface of the liquid. So in summary, if the density of the liquid is equal to if the density of the body is equal to the density of the liquid, then the body will float wholly immersed in the liquid. That is, the body will float just below the surface of the liquid. This is the core concept. I hope I was able to explain that the body floats when rho 1 is equal to rho 2, that is, the density of the body is equal to the density of the liquid. And in how the body floats inside the liquid wholly immersed. That is, just below the whole part of the body is immersed in the liquid, and so and it floats just below the surface of the liquid. In the next video, that is case 3, I will discuss what happens if the density of the body is less than the density of the liquid. So that is all for this video. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Stay tuned for the upcoming videos on this topic. Thanks for watching, and until the next video, take care and bye.